Hello students, today I am going to discuss another problem on electrostats based on Gauss theorem. The question is, the electric field inside a sphere which carries a charge density proportional to the distance from the center P equal to alpha r. Okay, not P, it is rho. Okay, so rho is the charge density inside a sphere given question dia ase, it is charge density. Okay, and it is given as rho is equal to alpha r, where alpha is a constant, right? Alpha equal to constant. So we need to find out electric field inside a sphere. Okay, so now let me draw this sphere first. Okay, if we will draw this, let me draw this sphere. Then if this is your center, okay, so you see its charge density varies as r, that is proportional to r. Okay, it is equal to rho is equal to alpha r. So let me take, we need to find out electric field inside this sphere. So let me take another, this sphere inside, which is a distance r. Okay, here the electric field will be symmetrical. So at the distance r, we need to find out the electric field. P is the electric field point. Okay, then surrounding this particular point P, we will draw a spherical Gaussian surface. Okay, this is your spherical Gaussian surface. This one is your spherical Gaussian surface. Okay, so according to the Gauss law, what we have is your integration E dot ds, okay, is equal to q in by epsilon. Now this q in is your total charge inside the Gaussian surface. Now here the total charge inside the Gaussian surface charge will be here. Okay, this is a sphere and its charge density varies like this, rho is equal to alpha r. So total charge q inside is the charge within this. So for this, what we will do, we will through a small volume take a small elementary volume here at a radius r dash from the center with a thickness of dr dash. Okay, dr dash. For this Gaussian surface, we have E dot ds is the electric field on the Gaussian surface, which is a distance r from this. So E dot is the is same on this Gaussian surface, E into 4 pi r square, because area is the 4 pi r square for the Gaussian surface. And this q in, for this q in, we can write the integration of q in, that means all the charges we need to find out inside this Gaussian surface divided by epsilon naught. Now for q inside, we will take this particular a সৰু elemental volume to আমি লম. সৰু elemental volume to কিমান হ'ব? এইটো এটা sphere হ'ব. এইটো এটা তোমাৰ sphere হ'ব. সেই sphere to thickness কিমান? dr dash, and radius কিমান? r dash. Is a hollow sphere. Okay, so let me put this sphere to be elemental sphere here. Okay, so this is a hollow sphere of thickness dr dash. Okay, now what is the volume of this? dv. Okay, volume of this small hollow sphere is your dv. dv equal to your 4 pi r square dr, because area into thickness. Now this charge density rho is your volume charge density. That means we can write here total charge q divided by volume is your alpha r. So okay, so it is your dq by dv is equal to alpha r. From this we can write dq is equal to alpha r dr. Okay, this is your rho. Okay, so from this the charge in the elemental volume is given by rho is given dq is equal to rho into 4 pi r square dr. Okay, so for this rho value is given as alpha into r. It is 4 pi r square dr. Okay, so this is your dq. So for this total charge will be from what we need ama corpora color charge like from 0 to small r. Okay, so we will integrate this. So since this is of radius r dash, so charge density at this particular point will be alpha r dash. Okay, so it will be integration of dq will give us q, and it will be integration of alpha is constant, then it will be integration of 4 pi alpha, this is r dash square. Okay, dv is equal to 4 pi r dash square dr dash. Okay, dr dash alpha r dash cube dr dash. So from these 4 pi is constant, alpha constant, so we'll have integration of r dash cube dr dash from 0 to r. So from these we can have total charge q inside the Gaussian surface as 4 pi alpha r dash to the power 4 by 4. Okay, now we will integrate this from 0 to r. So from these what we have is your q in is your 4 pi alpha r to the power 4 by 4. So this 4 will got cancelled and we will be left with pi alpha r to the power 4. Okay, pi alpha r to the power 4. Now this is the q inside, total charge inside. So what was our equation for the Gauss law? E dot ds from this equation, exactly from this equation we can write E into 4 pi r square is equal to q inside is your pi alpha r to the power 4 divided by epsilon naught, right? So this is our equation. So what will be the electric field? So what will be the electric field from this? E is equal to pi alpha r to the power 4 divided by 4 pi r square epsilon naught. Okay, so this r square, this r to the power 4 will give you r square, pi will got cancelled, so we will be left with E is equal to alpha r square 4 epsilon naught. Okay, so the electric field inside this sphere at a distance r from the center of the sphere is alpha r square by 4 pi epsilon naught. Okay, I hope you all have understood this problem. It is based on Gauss theorem. Thank you.